So next topic, cardiac output. So what is cardiac output? So the amount of blood pumping out from the heart will be called as cardiac output. Okay, cardiac means heart output. So the amount of blood which is pumping out from the heart will be called as cardiac output. So the methods of measuring the cardiac output has five method. Okay, types of method. First one, fixed method, dye dilution method, indicator dilution method, thermal dilution method, and impedance change. So these are the types of method for measuring the cardiac output. So the amount of blood pumping out from the heart, okay, will be called as cardiac output. So first method, fixed method. So using fixed method, we are going to find out the cardiac output. Okay. So this is based on the determination of cardiac output by the analysis of gas keeping of the organism. So this method of analyzing is similar to your gas keeping of the organism. So any organism which will be filled with the gas, while analyzing that gas concentration in the organism will be similar to your cardiac output measurement or analysis. Okay. So the cardiac output will be calculated continuously by infusing the oxygen into the blood. So we are going to inject oxygen into the blood of the heart, okay, or removing it from the blood. So after injecting, we are going to remove the air, that is oxygen from the blood, and measuring this amount of oxygen in blood before and after its passage. Okay, so we are going to calculate the cardiac output by injecting the oxygen into blood as well as removing the blood. So the amount of blood measurement, the amount of blood. The amount of oxygen which is present in blood before sending the oxygen and after sending the oxygen, okay, that will be measured for calculating the cardiac output. Next, let I be the amount of infused or removed oxygen per unit time. So for per unit time, uh, for a time period, you are going to inject a oxygen, okay, into the blood. I is equal to the difference between amount in blood arriving at and departing from it. So there is nothing but I value will indicate the difference of injecting the oxygen into blood and as well as the removing the oxygen from the blood. Okay, that difference will give the I value. Okay, so I is nothing but your cardiac output. So CAQ is nothing but removing the oxygen from blood. Okay. CVQ is adding the oxygen or injecting the oxygen into the blood. Okay. So that the concentration is given by CVQ. This is concentration of ventricular. Okay. This is concentration of arteries. Okay, so arteries and ventricular will give the difference of these two concentration will give the cardiac output I. So here F will indicate the blood flow in the heart. Okay, so F equal to dm by dt divided by Ca minus Cv. So dm by dt is nothing but oxygen. How much amount of oxygen consumed by the blood. Okay, consumed by the blood of heart. Okay, that is given by dm by dt. Why they given dm by dt means change in consumption. Okay, that is quantity of oxygen will be changing with the time period. Okay, so this time you will be sending some oxygen, some amount of oxygen. It may be added few to the same oxygen at next minute. Okay, so that will be indicated by d by dt, change in time period. Okay, consumption of oxygen will be changed with the time period. That's why they given dm by dt. But ca minus cv, so arterial concentration, that is arterial concentration means where you are injecting the arterial place, that is arterial region only you will be injecting the oxygen into the heart of blood. Okay, that's why first they taken as ca, and then cv. Cv is nothing but venous concentration, so where the oxygen taken out. Okay, removed from the heart of blood. Okay, that will be represented by venous. That place name, the region where we are taking the oxygen out, that will be represented by the venous concentration of oxygen. Okay, so all this will be represented in terms of in units of liter per minute. Okay, so for per minute how many liters are injecting and taking out. Full setup for the fixed method for calculating the cardiac output. See here, you are injecting the oxygen, okay, to the arteries. Arteries means the aorta um, nerve will be called as arterial blood. So the blood in the arteries will be called as arterial blood. So through that only you are going to inject the oxygen. Okay, so after injecting, where you are taking the oxygen mixed with the hot blood will be purified by the lungs after entering into the arteries. I think you all know the structure of heart or working of the heart. Arteries ventricles இருக்குமா. So arteriesல என்ன what you will be collecting, what type of blood will be collecting, you will be collecting the impure blood from the all parts of the body. Okay, that will be sent to the heart, sorry, sent to the lungs for purifying it, where oxidation will be done. That is nothing but oxygen will be added to the blood. Okay, the so you will be getting the purified blood after getting from the lungs. Okay, oxidation process done in the lungs, you will be receiving the purified blood to the ventriculars or left side of the heart. Okay, so there, from there you will be sending the purified blood to all the parts of the human body. Okay, this is the working of heart. So in the same manner you are going to inject the oxygen in the arteries. Okay, so this will be sending to the lungs. Okay, after lungs it will be reaching the right side, sorry, left side of the heart, where you are going to measure the blood or take out or remove the oxygen from the blood. So this is the oxygen removing needle. Okay, this is catheter. Okay, so through the catheter only you will be removing the it will be like what to say, nerve like manner. So needle, it will be removing the oxygen from the heart. Okay, which will not be affecting the heart of the human body. So by through the catheter it will not affect any damage to the heart. Okay, So here you will enter the oxygen, here you will remove the oxygen. So the difference of these two value will give the blood flow in the heart. Okay, the blood flow in the heart is nothing but cardiac output. Okay, so how much amount of blood is passing through the heart for per minute is said to be cardiac output. Okay, so the blood returning to the heart from the upper half of the body has a different concentration of oxygen from the blood returning from the lower half. So this is nothing but the upper part of the body will have different concentration of oxygen. Okay, so the lower part means leg, thigh, from the bottom of the human body, you will be receiving the blood to the heart. That blood will be having different concentration. Okay, comparing to the upper part of the human body. Upper part means from the head. Okay, from the head to heart. So the oxygen concentration measured by the spirometer. So the oxygen level in the blood will be measured by spirometer. Okay, spirometerங்கிறது ஒரு device which will be measuring the oxygen concentration in blood. The arterial venous concentration difference is measured by drawing samples through catheter placed in an artery and in the pulmonary artery. This is nothing but the arterial venous concentration means while you are injecting the oxygen into the arteries region of the heart, the amount of oxygen concentration will be measured. Okay, next, another one concentration will be measured at the removing of oxygen, that is venous part. Okay, at venous region, you will be measuring the same amount of oxygen. Okay, so venous concentration as well as arterial concentration will be differing. Okay, that difference value will give the blood flow in heart. Okay, so advantages of fixed method. The fixed technique is non-toxic. Okay, because the indicator is the normal metabolite. So normal metabolite means it will not affect the blood value. Okay, so that will not be mingled with your blood, that is partially removed as blood passes through the systemic capillaries. You can remove the oxygen from the blood because it will not mix with the blood. Okay, completely. The cardiac output must be constant over several minutes so that the investigator can update the slope of the curve for oxygen consumption. So you can get the cardiac output like a curve manner. Okay, by considering the oxygen consumption. Okay, for the several minutes, you for several minutes you will be taking the oxygen consumption of the blood. Okay, so on taking that you will be getting an curve for the cardiac output. So time period 1, time period 2, time period 3, time period 4, that means 5 minutes, after 5 minutes, 15 minutes, 18 minutes, 20 minutes, like that. For different time period you will be taking the oxygen consumption level in the blood, hot blood. Okay, so that you will be getting a curve that is said to be cardiac output curve. Okay, so the presence of the catheter causes a negligible change in cardiac output. So catheter will be similar to your what to say, like a nerve in the human body, so it will not affect any changes for the cardiac output. Okay, next method, indicator dilution method. So this is based on the principle that we if we introduce an indicator. What is indicator? Here we are going to introduce indicator in the blood circulation of the heart. So what is indicator in chemistry? Anybody knows what is indicator? What is indicator? What is indicator in chemistry? Here we are going to use an indicator to mix with the blood. Okay. So in previous method, in fixed method, we used oxygen, that is O2. Okay. Added with your blood circulation of heart. So using that, you are measured blood flow in the heart, that is cardiac output. But here we are going to use indicator. What is indicator? Very good. Very good. A substance which will change the color in acidic as well as in basic. Okay, acidic இதில் போடுறப்ப you will be getting some color. அதே வந்து பேசிக்ல போடுறப்ப you will be having some other color. For example, phenolphthalein. Okay, in your chemistry you will be learnt uh, phenolphthalein. பார்த்திருக்கீங்கல்ல, it will be changing into magenta color if you pour that in some liquid. Magenta color will be appearing. ஸோ அது சொல்லலாம். அப்புறம் நிறைய இருக்கு. ஓகே, இண்டிகேட்டர் நிறைய டைப்ஸ் ஆஃப் இண்டிகேட்டர், பட் டக்குன்னு இதுதான் ஞாபகம் வருது, ஃபினால்ப்தலீன். ஸோ இட் வில் பி கிவிங் கலர் ஃபார் பேசிக் ion one color, and then for alkaline one color. Okay, another color, the same color will not be appeared for both the base. So here indicator going to be used to mix with the blood of heart. So indicator will be diluted completely with your blood. Okay, அதனால தான் இதுக்கு நேமே indicator dilution method. So and then we are going to measure the concentration of indicator with respect to time. So we can estimate the volume flow of blood. Okay, so on measuring the concentration of indicator, we can find out the volume flow of blood in the heart. Okay, because here indicator is going to mix or dilute completely with your blood. On finding the dilute indicator concentration, you can able to find out the blood flow of heart. So this is the diagram, but it is given in open circulation, it is not in closed circulation. Okay, open circulation means the joints are not connected to each other. Okay, so openly left. This is small sample setup for the indicator dilution method. So here you are going to inject the indicator in the blood vessels. Okay, blood vessels of heart, and then it will be diluted with your blood. So after some time you will be detecting the blood flow, or detecting the concentration of that diluted indicator using detector. Okay, using detector, this is detector. Using detector you are going to find out the concentration of indicator level in the blood of heart. Okay, that will be recorded by recorder. Okay, so this is the indicator dilution method. So an indicator I is going to be mixed with the blood with a known injection rate. So the rate, the amount of indicator which going to be injected will be known by us. Okay, so this much of amount will be injected into the indicator. The concentration C of the indicator is measured after mixing. That means after some time, after diluting completely with your blood, you will be measuring that or detecting that concentration of indicator. Okay, that will be kept as C. Okay, injecting I, after injecting or after dilution you will be taking the concentration of indicator as C. So I by C will give the F. F is nothing but flow, blood flow in heart. Okay, which will be taken for the unit liters per minute. Okay, for the minute how many grams or liters of blood is flowing in the heart. will be measured. So let m milligram of an indicator is injected into the right heart. So we are going to inject an indicator in the right heart. Okay, after passing through the right heart, lungs and left heart, the indicator appears in arterial circulation. Okay, so after injecting that indicator, it will be circulating the blood to the right heart, lungs, அப்புறம் தான் left heart. So திரும்ப left heart வரப்பதான் you are going to measure the indicator concentration. Okay, so the presence of the indicator in peripheral artery is detected by a detector. Okay, so in the peripheral artery only you are going to measure the indicator concentration value. Okay, using detector. So the output of the detector is directly proportional to the concentration of indicator. So the detector output is nothing but concentration of indicator. So the detector is displayed on a chart recorder with respect to time. So there measured concentration level will be displayed in the chart of recorder. Okay, with respect to time. So concentration will be in the y-axis, x-axis you will be having time period. Okay. So with respect to time, you will be getting the concentration level of indicator. When a given quantity of m naught of an indicator is added to a volume V, the resulting concentration C of the indicator is given by. So this is nothing but m naught quantity of indicator going to be added with the volume V of blood. Okay, volume of blood. So volume of blood V taken. So m naught amount of indicator is going to be added with this blood amount. So that result, that is after diluting the indicator completely with your blood, your result of concentration of indicator will be taken as capital C. Okay, if you add some more quantity of indicator to the same blood, okay, then it will be represented by del C equal to m by v. Instead of m naught, you will be using m by v. Okay, so change in concentration level of the indicator, because we are going to add some more quantity to the blood, quantity of indicator to the blood. So this is your plot of concentration of indicator with respect to time period. So time period will be taken in the x-axis. So concentration of your indicator is taken along the y-axis. Okay, so you'll be having high peak and then secondary peak, and then it will be going parallel to the blood flow. Okay, so parallel means similar to your blood flow, your indicator also will flow along with the blood. That is the meaning if you get parallel lines in the concentration value. Okay, that is nothing but parallel means completely diluted with the blood. So blood similar to blood flow, your dilute that indicator also flowing. So a common, so here they given that point. During the first circulation period, the indicator would mix up with the blood in a small quantity. After that, there is a rapid change of concentration. This is caused by rising portion of dilution curve. So first at starting you will be injecting small amount of that is indicator, okay, to the blood. So you'll be getting like this curve at starting. After that you will be adding more concentration of indicator to the blood, so you'll be getting the peak level. Okay, after reaching maximum, the concentration of indicator decreased exponentially. So after reaching maximum value, it will be the concentration value of indicator will be decreasing exponentially with respect to time. So after that, a second peak will be appearing. So second peak is nothing but this one. So after peak, what happens? It will be decreasing gradually. The concentration of indicator decreasing gradually, and then it will appear a small peak after a high peak. Okay. A second peak would then appear then when the indicator is completely mixed up with the blood. So now the indicator going to mix completely with the blood, then the curve will become parallel to the time axis. That means, so இந்த இடம் என்ன ஆகும், second peak அப்புறம் your curve will be going parallel to your time axis. Okay. So இப்படியே parallel போனுச்சுன்னா என்ன ஆகும், that is nothing but your indicator, okay, completely mixed with the blood. So the now you can measure the blood flow by measuring the concentration of indicator in the blood, okay, which will be similar to the blood flow. So in this manner you will measure. Next, dye dilution method.